Let's talk about radians. A radian is another unit of measurement for angles, and the conversion rate for degrees and radians can be given by the following equations. Now, there's a couple equations that people will occasionally use, so I'll give you both of them. Remember that a full rotation for a circle is 360 degrees, and in terms of radians, that is equal to 2 times pi radians. And remember, hopefully, pi is an irrational number, and it's approximately equal to 3.14159, but this is an irrational number, so those digits go on forever. So that's just an approximation, and the even shorter approximation is 3.14 that people will frequently use. So this is one of the equations that we can use for conversions. Another one that is common is 180 degrees, which is a half rotation of a circle, is equivalent to pi radians. And so that means that half of both of those is that 90 degrees is equal to pi over 2 radians. So these are all possible equations that you can use for conversions. Let's go ahead and use those in example 3. It says, convert the following angles into radians. Now, I've already given you this one, but we could use any of them. So if I'm starting off with 90 degrees, and I would multiply this by, I want to cancel out the degrees. And in fact, I'm going to write out the word degrees just so that I can emphasize the cancellation. So if I multiply this by the conversion fraction, I want degrees in the denominator. So 360 degrees is equivalent to 2 pi radians. And so what ends up happening is I have a degree in the numerator and I have it in the denominator, so those will end up canceling out. And now if I multiply the fractions, I would have 180, because 90 times 2 is 180, times pi radians divided by 360. And if I simplify that fraction, that just ends up becoming pi over 2 radians. So I'm going to go ahead and box that answer. Now, negative 37 degrees, I can do the same thing. So I'm going to do negative 37 degrees. And again, you can use any of the equations that I wrote up above. So why don't we maybe do the 181? So 180 degrees is equivalent to pi radians. So the degrees and the degrees will cancel out, and this will give me negative 37 pi radians over 180. Now, this is a fraction and it's an exact answer, but sometimes you'll want the decimal approximation. So that's something that you can definitely throw into your calculator. And that comes out to be approximately negative 0.65 radians if you throw that into your calculator. Convert the following radian measures into degrees. Now notice that neither of these angles have the unit of measurement written out. So there's a note here, and it's an important note. It says, if an angle does not have units attached to it, we assume that the angle is measured in radians. So we want to take 5 pi over 3, and this is radians, even though it's not written. And I'm going to go ahead and multiply that. I want a conversion factor where the radians are in the bottom. So we know that pi radians is equal to 180 degrees. And if we do multiplication now, the radians and the radians will divide since one's in the numerator and one's in the denominator. Same things will happen with the pi's. Those will cancel out. And then 180 and 3 are both divisible by 3. So if I divide that by 3, that would leave me with 1. And if I divide 180 by 3, that would leave me with 60. And so now if we do the multiplication across, we get 5 times 60 degrees, which ends up simplifying to 300 degrees. And if it wasn't clear, the degree symbol is this dot or circle in the superscript, or you can write out the word degrees. Either is fine. Okay, so same thing here. We have 18.7 radians, and I want to multiply that by pi radians in the denominator and 180 degrees in the numerator. So the radians will cancel out, and we get 18.7 times 180 degrees over pi. And this would be the exact answer. And you can definitely write out a decimal approximation. So if you threw that into your calculator, that is approximately 1071.43 degrees, like that. Example 5 says, find two positive and negative angles using radian measures that are coterminal with pi over 3. So similar to the example where we did it when it was degrees, we would just add full rotations, but this time we're working in radians. And so a full rotation in radians is 2 pi. So what I'm going to do is I'm going to add 2 pi to this, but these are fractions, and so we need to find a common denominator. And so this is the same thing as pi over 3 plus 6 pi over 3. So basically, I found a common denominator, and now if I combine those, that would give me 7 pi over 3. It turns out that when you're working in trigonometry, you have to be really good with fractions because you're going to do a lot of adding, subtracting, multiplying, and dividing of fractions. So fraction algebra and fraction arithmetic is something that you want to make sure that you're very comfortable with. And if not, please either, brush up or reach out to me, and I'm happy to help you with that. So this is one of our positive coterminal angles. I'm going to add another full rotation to that, which is plus 2 pi. So that would be 7 pi over 3 plus 6 pi over 3, and that gives us 13 pi over 3. So here are the two positive coterminal angles. All right, so now we're going to go in the other direction, and we're going to subtract 2 pi from pi over 3. So that would be pi over 3 minus 6 pi over 3, and that is going to be negative 5 pi over 3. And I'm going to subtract 2 pi one more time, which is another full rotation in the clockwise direction. So negative 5 pi over 3 minus 2 pi is the same thing as negative 5 pi over 3 minus 6 pi over 3, which is going to be negative 11 pi over 3. So these are our two negative coterminal angles.